Okay, we're going to do a quick recap. We're going to do a quick recap, and we were talking about faces, vertices, and edges. Now, I would like 3 volunteers. I need somebody to explain to me, guys, what is a face? Who can tell us what is a face? Sanya, what is a face?
A face is how you find how many faces an object has, like this cone that we have on the screen right now, ma'am. It has
this
that
would be
one face.
So
because
we can call it like a surface, right?
Yes, ma'am, basically, in other words.
Yeah, like the surfaces of my shape, right? Surfaces of what kind of shape specifically? What kind of shape do we have here?
It's a cone, ma'am.
It's a cone, but what kind of shape, what do we call it when we put all the different types of shapes together? Or these kinds of shapes together? Starts with a 3. A 3. It's not flat. It's not like that. It's not like a square.
3D, ma'am.
Good. Yes, it's called 3D. It's the surface of a 3D shape. There we go. That's what I was looking for. It's not a trick question. I think you got it right, my dude. I'm just testing you. Don't worry. You got it right. Well done, Sangye. Well done. Buhle, can you tell me what is a vertex or a vertex, or what are vertices? Do you know, my sweetie? You can unmute.
Okay. Ma'am, pardon?
What are vertices?
It's the lines of a 3D shape.
Not quite. So you're mixing that up with something else.
It's the points of a 3D. It's the pointy parts of the 3D shape.
Okay, good. Okay, we can call it the pointy part, or what can we call it exactly? Like when you get there and you go that way. What is that called?
Ma'am, I forgot the name.
Oh, they're called corners, dude. They're just called corners. Okay, I don't want you guys looking at the shape. I think you guys are confusing what I'm saying to the shape. I'm not talking about the shape. I'm just talking in general. What are vertices? What are vertices? What is a vertex? It's a corner. Okay.
Yes, ma'am.
Excellent. Well done. Well done. All right. I need somebody to tell me what is an edge. Does anybody remember what edges are? No worries, Unati. Anybody remember? I know Sangye knows. It's not the apex. I'm going to tell you that now. Mutevang, do you remember what an edge of the shape is? What an edge of a shape is?
I think the edge of the shape is where the I think the edge of the shape is where there's lines on the shape.
Okay, good. But what do these lines do? What do the lines do?
Where the lines join the shape.
Not the shape. You were almost there. What parts of the shape does it join together? Lines that join.
It makes the faces. It makes the faces join together.
Yes, good. The faces. It's where the faces join. So it's the lines that join the faces. So if I have an edge, like think about if I have a cube, right? If this over here is my edge, that edge joins this face to that face. You see it?
Yes, ma'am.
Okay, excellent. So my edges are the lines that join my faces together. All right, okay. Okay, everyone. So I need to ask you guys, what is the name of this shape that we're looking at down here? Who remembers what is this shape called? Type it in the chat. What is this shape over here called, guys? Excellent. It's called a cone. Good stuff. Lelentle is starting again with her question mark. Is it a cone? Don't know. What is it? Don't ask me. Tell me. What is it? Good. It's a cone. Right. I'm going to ask you guys now, how many faces does a cone have? Yo, I'm getting very like many conflicting answers. I'm getting many conflicting answers. I hear someone say, Tabisa's like, IDK, I don't know. I don't know. Bunte, what do you say?
I think it's one, ma'am.
Okay, which one? Which one are we looking at?
The bottom one.
Okay, so this one, right? Okay, so here we have
Yes,
one face. Okay, great. What about this part though? What about this part? Is this not a face?
Which one, ma'am?
This part over here, the one that I'm coloring really badly. What about this part?
I think it's a face.
It's a face. Yes, it's also a face. Yeah, we've got another face. Okay. Canva Y3. I mean, if we think about it, guys, this face that I have over here goes all the way around, right? Because if I'm holding a cone, it goes, I'm just holding one shape all the way around. So that makes up one face. And then we've got the top part that Bunke just told us about. So that's one. And the one that goes all the way around, that's two. So I'm going to ask again, Bunke, how many faces does the cone have? Oh no, I think she's frozen. How many faces do we have, Bunke? Two. Excellent. Good. We have two faces. Okay, well done. Amazing stuff. Awesome. Mpo, tell me, how many vertices does my cone have? Hi, Mpo. Sure. Okay. Mpo's not unmuting either. I don't know, maybe if it's a problem on my side, but I'm seeing a lot of you guys saying, some of you are saying 0, some of you are saying 1. Hi, Mpo.
Ma'am?
Hi, Mpo.
Hi, ma'am.
Hello, my sweetie. How many vertices does my cone have?
1.
Oh, where is it? Where is it?
At the top.
Okay, so
At
the
the
very,
top.
very top of my shape. Good. And what do we call this? Do you remember what we call this very top of my shape?
An apex.
Apex. There we go. All right, it's called an apex. Well done. So I have one vertex. Excellent. It's called one. When it's one, we call it a vertex, and it's called, many is called vertices. Very well done, Paul. All right, Olwa. How are you doing, my dude?
Hi, Miss.
How are you doing?
Good.
Excellent. All right. Are you going to tell me, Olwa, how many edges do I have on my cone?
Edges.
Mm-hmm.
Miss, I'm not sure like how you calculate or like the edges, where you find the edges, because I
Okay,
don't think
so-
there's.
Okay, so if you look at this cup that I've got over here that I've been drinking out of, if I'm standing, let's say I'm a tiny little man and I'm standing on the top of my cup, where do I need to go? If I go any further than this, what's going to happen? If I go over here right to the edge, what's going to happen if I go over? If I take one more step, what's going to happen?
You're gonna fall?
Yeah, I'm going to fall over. So what does it make this part of my cone, this part right over here?
The edge.
That's the edge. There we go. Okay, so now I want you to look at my cone and tell me, is there a place where I can find a place where, like, let's say, for instance, I'm a tiny man, I'm standing, and I'm going to fall over. Can we find a place like that?
Yes. Yes,
Can you
there
see
is.
it? It's over here, right?
Yes.
Okay, but this particular edge goes all the way around my cone. So that's one edge. Can we think of any other place on this shape where there's another edge?
Is it not like on the triangle part?
No, remember, this is a vertex. This top part over here is a vertex. This is a vertex. Okay. Is there going to be anywhere else on my shape where I can like kind of fall over the edge?
No,
No. So how many edges do I actually have?
you have one.
Excellent. I have one edge. Amazing stuff.
So
Ola.
it doesn't, so the edge doesn't have to be a circle. It's just anywhere where you can fall over, like if you think about it.
Yes. Okay. So let's say, for instance, Ola, if I had a cube, right? If I had a
Yes.
cube like this. Now, because this over here, this corner over here, this is a vertex, and that is a vertex. Do you see that in between my vertex, there's an edge? You see it there? Because if
Yes.
I'm standing over here as a tiny little man, if I go over here, I'm going to fall over. You see that? Now there's an edge. And if I come this way, I'm going to fall over the side. So here's another edge. And if I go that way, I'm going to fall over that side. That's another edge. You see that? But in this one,
Yes.
because it's a round shape, okay, if it's a round shape, how many edges do I have? I only have one.
If it's a round shape, you have one. And if it's if it's a shape that has four sides, you have four edges.
I have four edges on the top, but I also have another edge here at the bottom, and another one here, and another one here. Okay, wherever we can find edges on the shape. Okay. It will become
Yes,
a little bit,
miss.
it will become a little bit more clear as we keep going. Okay.
Okay.
All right, excellent. Well done. Very nice question. I appreciate that. Excellent. All right. So let's look at the next one. Everybody tell me, what is this next shape that we're looking at? What is this shape over here called? This next shape is called it's a cylinder. Excellent. Okay. And we're going to have to move just a tiny bit faster. Bonolo, how are you doing?
I'm doing good, ma'am.
I'm glad. I'm very glad. All right. Can you tell me how many faces do we have on this cylinder?
2.
Oh, just 2. Which parts?
Ma'am, the one on top
Mm-hmm.
and the
And?
one in front. The
And
one in front.
Okay, but what about, I'm going to draw it like this.
And the one at the bottom.
And the one at the
3,
bottom.
ma'am.
You forgot the one at the bottom. How many is that?
3, ma'am.
3. I've got 3 faces. You almost forgot the one at the bottom. Okay, well done. Okay. Awesome. All right. Okay. I need another volunteer to tell me how many vertices I have. Who knows? How many vertices do I have, guys? How many corners do I have? Good. I'm seeing everyone in the chat tell me I've got 0 corners. I don't have any vertices because there are no sharp points on my shape. Right. Last one. How many edges do I have? Excellent. I see it. I've got 2 edges. All right. Very well done, guys. I can see you guys get the idea. Okay. But today's lesson is actually about calculating surface area. Now, hands up. Does anybody remember what we said surface area is? Do you guys remember what surface area is? Who can remind me? Buntle, do you know? Buntle's still flipping through her books, trying to remember what the surface area is. Yonela, it's not quite L times B. Do you remember, Buntle?
the area when the shape
Sure, my sweetie, we didn't quite get that.
is the shape.
Okay, it's not quite the volume of a shape. I think that's what you're saying. That's not quite it, guys. Do you remember, Onka? Hi, Onka. Okay, Onka's it's not unmuting. All right, guys. So the surface area of a shape is the total area of all the sides. Okay. All the sides of my shape. Okay. So what we're going to be looking at today is the area of this cube. Now, I'm going to tell you guys that this side over here is 3 centimeters. Okay. If this side is 3 centimeters, I'm going to look at the first part of my shape. I'm going to look at this part of my shape. Guys, what shape do I actually have? What shape am I highlighting over here? What kind of shape is this? Good. Oops, Sangit, just the one side. Just this one side, it's a square. Now, if I had to calculate the area of a square, I'm going to calculate side times side. I just want the area of the side or one face. I'm just calculating the area of this face. Okay, now because this area is the area of a square, that means all the sides are equal. So if I'm going to calculate the area of the square, I'm going to say that the area of my square is 3 centimeters multiplied by 3 centimeters. Therefore, my area is equal to 9 centimeters squared. But this is a 3D shape. It's not just one face. Can I ask you guys again, how many sides of a cube are there? How many faces of a cube do I have? Yes, Emmanuel.
Ma'am, we have 6.
Excellent. So if I have 6 sides and each side has an area of 9 centimeters squared, how can I find the total area of all the sides? What do you think we can do?
We can times 9 times the faces of all the
Good.
yeah 6.
Good. 6, good, because we have 6 faces. So I'm going to take 9 times each of the sides and the back side and the bottom and the other side. Okay, excellent. So I'm going to go my surface area. Well done, Emmanuel. My surface area, SA stands for surface area, is going to equal to 9 centimeters squared times 6. Therefore, my surface area is 54. And Etiken, you forgot to write centimeters squared. Squared. Do not forget the squared. We're calculating surface area, so we must not forget the squared. Let's try this again. Let's try this one again. All right, I'm going to leave the formula up for you. Area is equal to side times side. Okay. If this side over here is 4 meters, Carrie, how am I going to calculate for this?
You're going to say 4 times 4, which equals to 16.
16 what?
16 centimeters squared. Yes.
Centimeters?
And then you're going to say 16 times the 6 size
Hold
of
on.
the cube.
Hold on, Carrie. It's not centimeters. What is it?
Meters, sorry, meters.
16 meters. Good. 16 meters squared. Good. And then I'm going to say surface area. How many faces of my cube are there?
There are 6. So you're going to say 16. So 16 times 6, which equals to 96.
96 what?
96 meter square.
Excellent. Please don't forget my meters squared. They're very important. Okay, very well done. Okay, can I get a thumbs up, thumbs down in the chat? how do we feel about this question for the cube? How are we doing? Excellent. Amazing. I'm seeing thumbs up all around. Sange says a quarter down. I'm seeing another. Snowy also says thumbs down. Okay, I think we're going to do one more and then we're going to move on, and I'm going to try and explain very, very slowly as we go along. Okay. All right. So if I say to you guys that this side down here is 5 centimeters. Okay. If this side over here is 5 centimeters, right? Now, this one face of my cube, this one face of my cube, if I just look at the face, okay, if I just look at the face of my cube, that is a square. And when I calculate the area of a square, I take the side times the side. And because it's a square, all the sides are equal to each other. This side is 5, this side is 5, that side over there is 5, that one is 5, that one is 5. They're all 5. All of them are going to be 5. So when I calculate for the area, I'm just going to say side times side. That's going to give me 5 centimeters times 5 centimeters. Therefore, my area is equal to 25 centimeters squared. Now, because it's a cube and I don't have just one face, I'm going to count how many faces I have. I have 1, 2, 3, and there's one at the back, 4, one over there, 5, and one at the bottom, 6. I have 6 sides or 6 faces to my cube. I then, to calculate the surface area, I have to go surface area is equal to 25 centimeters squared multiplied by the number of faces I have, which is 6. And that's equal to 25 times 6 is going to give me 150 centimeters squared. Okay, excellent. I'm seeing many, many correct answers in the chat, and that makes me feel very good. Okay, loving that you guys are getting how to do this. Okay, please don't forget that the SA stands for surface area. Okay, this SA over here stands for surface area. I'm just being very lazy. Okay. Oh, sorry, Maya. Therefore, surface area. Thank you, Maya. Therefore, surface area is equal to 150 centimeters squared. Okay. Somebody says, how do you calculate the area? Mkhele, we looked at the formula for area over here. Area is equal to side times side, just like Teacher Cat said in the chat. Area is equal to one side times the other side. Okay, now I need to complicate your lives a little bit. Okay, we are going to be looking at this shape. What is this shape called, guys? Tell me in the chat, what is this shape called? Let's saying is a rectangle, but this is a 3D shape and not a 2D shape. So it cannot be called a rectangle because a rectangle is 2D. Good, it's called a rectangular prism. Okay, it's called, and then I stopped at rectangular. Sorry, guys, a rectangular prism. Now, I need to ask you guys, tell me in the chat, everyone. Okay. Do the faces of a rectangular prism look the same like in a cube? Are they the same? Remember when we did the cube, they all looked the same. They were all squares. It was all made up of squares. Is this one made up of the same type of face? No, it's not. It's not made up of the same type of shape. So we cannot use the same type of idea that we use to calculate the surface area of a cube to calculate the surface area of a rectangular prism. So what we're going to do is I'm going to take my rectangular prism and I'm going to break it up into its faces. And I'm going to start with this face over here. This one over here. This one. this face. Okay, now if I have to draw this face flat down, okay, I'm going to draw it like this. I'm going to ask you guys, what is the length? What is the longest side of this rectangle? Excellent, Ndine. Well done. It's 8 centimeters. Okay, this is my longest side. 8 centimeters. We're going to call this side the front. Okay. We're going to call this side the front. And what is the breadth? What is the short side? Excellent, Maya. Well done. Ooh, Jaden, be careful. Remember, the 2 doesn't actually work here because we're working in this shape over here. Okay, and if this is 5, this over here is also going to be 5. So my breadth over here is going to be 5 centimeters. Excellent. This is my front side. This is front. Okay, good. Now from here, I'm going to keep moving around my shape. So the next part of my shape that I'm going to do is the top. Okay, is the top. Now, if I'm doing the top of my shape over here, it's going to be connected to the front. What is the long side of this shape? Danae says, wait, ma'am, isn't the 5 centimeters the height? Yes, it is. Danae, you're absolutely right. It's the height. But when I break down a 3D shape into a 2D shape, the height then becomes the breadth of some of the sides. Okay. Okay, it will make sense in just a little bit. Okay, so now for the top, my long side is 8 centimeters. What is the size of my short side, guys? What is the side of my breadth? The one over here. Excellent, it's 2. Because if this side over here is 2, that means this side over here is also 2 centimeters. So this becomes 2 centimeters. Okay. Maya, I hope you're seeing it. Okay. Excellent. Then, I hope you guys are with me. From the front, I'm going to the top. Where am I going to go next, guys? What is the side over there? The one that, if this is the front and this is the top, what am I going to call the side that I'm going to do next? It's going to be the back, right? Snowy, can I ask you to DM Teacher Cat, please, my sweetie? Can you please DM Teacher Cat? Okay. Sang not the sack side, the back side, the back side. Okay, good, it's the back. Now, I want you guys answer yes or no for me in the chat. Do you guys agree with me that the front side, because this is a rectangular prism, the front and the back will look exactly the same? You guys agree with me? They will look exactly, they will be identical because I'm making a box. So I'm going to write here, I'm going to draw a box or a rectangle for the back, and the back and the front are going to look exactly the same. So I'm going to have my long side be 8 centimeters and my short side is going to be 5 centimeters. Now, guys, I have done the front, I have done the top, I have done the back. Where am I going next? Where am I going next? Excellent, Ndine. What am I doing next? The bottom. I have to do the bottom. Saisha and Maya, hold on. We're going to get to the sides. I'm just trying to go around I'm going around my shape first. Okay, I'm going around. So we're going to do the bottom next. And I'm going to ask you guys, which other side looks identical to the bottom? Which side looks exactly like the bottom? The top side. Excellent. The top side looks exactly like the bottom side. So I'm going to draw another rectangle. And this rectangle for the bottom is going to look exactly like my top. So 8 centimeters. And then over here, I'm going to have 2 centimeters. All right. I'm going to ask you guys, everybody who has their hand up, can I ask you to put your hand down for me, please? Everyone hands down, please. Thank you. Now, can I ask you to put your hand up only if you have a question? Okay. Please put your hand up if you have a question. Okay, Sanye, let me take your question, my dude.
Ma'am,
Yes.
I'm kind of confused on how like we calculating the surface
Okay.
area.
Okay, so what we're going to do, remember that the surface area is the total area of the sides of my 3D shape, right?
Yes, ma'am.
So now, if I'm going to calculate the area of this side, I need to know what the length is and what the breadth is, because what is the formula for area, Sanye?
Length times breadth.
Excellent, it's length times breadth. But because this is a 3D shape, I have to do each side separately. You get what I'm saying?
Yes, ma'am.
So I first have to find out what are the dimensions of my front side, what are the dimensions of my top, my back, and the bottom. Which two sides am I missing now?
Your front and the top.
Okay, I've got the front and I've got the top, and I've got this side here at the back, and I've got this side there at the bottom. I've got this side here at the bottom. Which two sides are missing?
The sides, ma'am.
The sides, like this one right here in front of me and the one there on the other side, hey?
Yes, ma'am.
Good, the left and the right side. Now, can I ask you, Sanye? I'm just going to add them on here. It doesn't really matter where we add them on. Right. If I have to calculate for them from here, what is this long side of my rectangle over here going to be? What is the length of my rectangle going to be? Of
So,
this one
ma'am,
here. I'm looking for the length of.
it's 5 centimeters, ma'am.
Excellent. It's 5 centimeters, just like what we've written over here. You see it. We've already written 5 centimeters. Yes? Okay.
Yes, ma'am.
What is the length of the short side? Of the short side. Of the side.
The short. Isn't it also it's 2 centimeters, ma'am.
It's 2 centimeters. Excellent. It's 2 centimeters. Okay, so this side over here, the short side is going to be 2 centimeters. Okay. What about the other side? Do you agree that this side over here, the one that we just did, and the other side are going to look exactly the same? Do you agree with me?
Yes, ma'am.
Good. So this side is also going to be 2 centimeters on the short side and 5 centimeters on the long side. Now here comes the work that we have to do. Okay. I'm going to name each of these. I'm going to name this one 1 and 2, 3, 4, 5, and 6. Okay. And now we have to calculate the area of each of these. Now I want the area of the part that I've labeled 1. Do you see the part that I've labeled 1?
Yes, ma'am.
Good. I want the area of that part. What is the area of 1? How am I going to calculate the area of 1? What's the length?
It's 8 centimeters, ma'am.
8 centimeters. Good. That's my length times. What's my breadth?
5 centimeters.
Excellent. 5 centimeters. So what is the area of 1?
40 centimeters squared, ma'am.
40 centimeters squared. Good. Now we're not done. We still need to find the area of 2, 3, 4, 5, 6. And when we find all of those areas, what are we going to do with them?
Ma'am, we must add them all up and then get the total.
Exactly, because that's what surface area is. Surface area is the total area of all of them. Do you get it, Simon?
So basically, ma'am, do I have to say plus 8 centimeters times 2 centimeters?
Good. Yes. So we're going to do the next one. We're going to go. The area of number 2 is 8 centimeters
times 2 centimeters,
which is
16 centimeters squared.
good, 16 centimeters squared. And we're going to do this for all of them. And then at the end, we're going to add them all together. See what I'm doing?
Yes, ma'am.
Excellent. All right. I'm going to give everybody a chance in the chat to put their answers down while I take Ola's question. Okay.
Okay, thank you, ma'am.
You're very welcome. All right, everybody, I want you guys to just pop in the chat for me. If you have an answer for 3, just go 3 dot and give me the answer, guys. And 4 dot, give me the answer. I'm going to collect all your answers and I'm going to put them together. So this is the area for 3, the area for shape 4. Give me all the areas in the chat that you can give me, and then I'm going to put them all together. All right. Thanks, Etoken. Excellent. All right, I'm going to take your question now, my sweetie. What's up?
Miss, like I'm a bit confused
Okay.
with like the rectangular prism, and I'm like when you like unbreaking it and you're doing it into 2D, and
Yes.
then it says the front, the top, the back, and the bottom.
Hmm.
So it's basically if you like make it into a shape, it's going to be a rectangular prism.
Yes. So think about, like, let's say, for instance, if I had to take this part here, these 2 corners here, right? And I folded them in and I connected them to this part and this part. Do you see how I'm going to have like a 3D box?
Yes.
So I'll show you here. I got a gift the other day, and this is what the gift looks like, right? So if we look at this box, what I've done here is I've got, this is my top or my front side, right? So I've broken down my front side into just this face. And then I know that this top side over here, see, this is my top side. This is also a rectangle. But now, if I look at this top side, which other side looks like my front side, not my top side? Which other side looks like my front side?
The bottom.
Ooh, the bottom is a little smaller than the front. Which other side is going to look exactly like my front?
The back.
The back, exactly, the back. Right, so when I started calculating, I calculated the front, and then I calculated the top, and then after the top, I went to the back. And then where do I go from there? If I go into front, top, back, where do I need to go next?
Then after you've done so it's front, top, back, then it's bottom.
Good, it's the bottom. So that's exactly what we did here. If you look, we first did the front, then we did the top, then we did the back, and then we did the bottom, right? But there are 2 sides missing. Which 2 sides are missing? This one, right?
The left and the right side.
Good, the left-hand side and the right-hand side. There we go. And then we put our box together. So what I've done here, what I've drawn over here actually, is my box, like almost as if I've unpacked my box. You see it?
Okay.
And that's how we put it together. Have you got it?
Yes, Miss. And can I also ask another question?
Yes.
With the length and breadth, I know like length is like isn't it the same as height?
Not particularly, because the height, okay, so the length is this long side that's on the floor. And the breadth is the short side that's on the floor. Now the height, remember when we're measuring your height, we measure you from the floor going up, yes?
Yes.
So the height is always going to be the measurement that starts from the floor going up.
Oh. Okay.
Okay.
Thank you, Miss.
You're
Yes.
very welcome. Awesome. All right, guys, I'm going to look at your answers now. I see your answers in the chat. Oh, that's okay, Bunke. I'm so sorry. Yo, guys, load shedding is the worst. Really. All right, I see your answers, guys. Thank you very much. Number 4. Number 4 is my bottom. Let me see number 4. Number 4. Okay, excellent. 8 centimeters times 2 centimeters. Oh, guys, this is easy. This is really easy for you guys. And number 5 is 10 centimeters. Let me see how you guys got to 10 centimeters. 5 centimeters times 2 centimeters. Indeed, 10 centimeters. Look where I'm putting my square. There it is. 10 centimeters squared, and number 6, as you guys say, 10 centimeters squared. Now, if we add all of these up together, right? If we add them all up together, my total surface area, therefore surface area is equal to 132 centimeters squared. Now, I need from you guys a thumbs up, thumbs down. Are we okay with the idea of surface area of a rectangular, I almost said a triangular, a rectangular prism? Taylor says up thumbs. Snowy's still a little bit confused, my sweetie. I need you to rewatch this lesson for me. Okay, we're going to do a quick recap of these on Wednesday. Okay, but this is how we calculate the surface area of a rectangular prism. Okay, we